How do we draw the irrational number square root 3 on the number line? Let's find out. So we have drawn ourselves a number line. Now we want to find out where is square root 3. So we know a few things about square root 3 just by looking at the number. Square root 3 is a positive number, so it is greater than 0. So we start from 0 and we will look to the right side of 0. Why is that? Because as we go from 0 to the right side, the numbers increase and we get to plus infinity on the number line. Similarly, we know that minus square root 3 would be a negative number and it will be less than 0. So if we were to find out, instead of plus square root 3 minus square root 3, we will start at 0 and we will look on the left side. Because as we go on our left side from 0, we will get to minus infinity on the number line. What else can we tell about square root 3? Well, we know that 1 square is 1 multiplied by 1, which is simply 1. Similarly, 2 square is 2 times 2, which is 4. So what we have is, if we square root 1, we will get 1. Because 1 square is 1, so 1 square root 1 will be 1. Similarly, if 2 square is 4, square root 4 will be 2. So if you do square root 4, you will get 2. Now, for the time being, I am just looking at the positive values, because one can argue square root 1 can be plus minus 1, and that will be correct, and square root 4 will be plus minus 2, that will be correct. But for the time being, I'm only looking at the plus values. So what this means is, if I have square root 1 over here, and if I have square root 4 over here, so square root 1 is actually equal to the number 1, and square root 4 is actually equal to the number 2. So square root 3 will be somewhere in between square root 1 and square root 4. So our answer will be somewhere between 1 and 2. That means that if we look at this space between 1 and 2, which is this space, so our square root 3 will lie somewhere in between, but we don't know exactly where. So let's find out more. So we have drawn the number line in a little bit bigger way, so we can actually have more space. Now we have drawn ourselves a unit square, and let's say we join the diagonals of the unit square. So what do we get? Unit square means each side is 1 unit. Each side of the square is 1 unit. So if we name the square ABCD, and if we focus on the triangle BDC, it really does not matter which diagonal you join, this one or the other one, and which triangle we consider. And you will see the reason why. So we are focusing on triangle BDC. So now we know this is a right triangle. Why? Because angle C is 90 degrees. It's a square, right? So this is a right triangle, BDC. So the side BC is 1 and side DC or CD is 1. So what can we tell about the length BD? Well, we know from Pythagoras theorem that BD square will be equal to BC square plus CD square. Now, why is that? Pythagoras theorem states that the hypotenuse square is equal to sum of squares of the other two sides. Now, BC is given as 1 square, and CD is given as 1, so this will be 1 square. 1 square is 1 plus 1 square is 1, so this is equal to 2. So we have BD equal to, or BD square we should say, is equal to 2. So if we take a square root on both sides, we will get BD is equal to plus square root 2. Actually, we will get it as plus minus square root 2, but BD is the measure of this side. So a measure of a length cannot be negative, so we are going to ignore the negative value, or we have BD equal to square root 2. So this length BD is square root 2. So we have square root 2. But is that what we're trying to find out? Answer is no, we're trying to find out square root 3. So let's see how we can use this to find out square root 3. So let's clean this up a little bit, and let's move our unit square on to the number 0. So left hand side of our unit square, we have merged it to the number 0 on the number line. So now what we have just seen is that this line highlighted in yellow, which is the diagonal, this is the measure of this is how much? This length is square root 2. So let's name this square. So let's say this side is A, this side is B, this side is C, and this side, this point I should say, is D. That means the point D coincides with the number 0 on the number line. Now what we will do one more small construction. So at point B, we are going to construct a 90-degree angle going up, right? And on that, we are going to go up 1 unit. So it will look something like this. It will look something like this. And then we will join this and this. So in other words, from point B, we drew a 90-degree angle. This is 90 degrees. And let's say this is point E. So we basically did a 90-degree angle on the length BD. So that angle B or EBD is 90 degrees. And on this, we basically went up by 1 unit. So this length is 1. So what do we know about the triangle BDE or DEB? Well, the triangle DEB is a right triangle. And we also know the length BD, that is this length, is square root 2, right? This is the diagonal, the length of the diagonal of our unit square ABCD. So unit square ABCD and BD is the diagonal. This is square root 2. So by construction, what we have done, so we are now looking at this triangle DEB. And by construction, angle B in this is 90 degrees. And we know that BE is 1 unit. And we know that BD is square root 2. Now, because this is a right triangle, DEB, what can we tell about the length DE or this length? So what can we say? What is this length? So as you can see, this is the hypotenuse, right? So we can say, let's try to write it over here. So we can say that, or maybe we can do it over here. So we can say that DE square equals BE square plus BD square, right? So hypotenuse DE square is equal to BE square plus BD square by Pythagoras theorem. Or now what is BE? Well, BE is 1 unit that we know by construction. So this will be 1 square. And what is BD? Well, we know BD is square root 2. So this will be square root 2 square, right? Or 1 square is 1 and square root 2 times square root 2 is 2. So what we have here is DE square is 3. So DE square is 3, or if we do square root on both sides, we get DE equal to plus minus square root 3, and given this is the measure of the side, it cannot be a negative number, or we say DE is plus square root 3. So for the first time, we have realized that this length, if we take a ruler or a scale and measure the length DE, this length now is square root 3. The value or the measure of this length is square root 3. So how are we going to get this length on the number line? Because that is what we want to do. We want to get this length on the number line. So we are going to take a compass. We are going to put the fixed end of the compass here, extend the other arm all the way till here, and draw an arc on the number line. So it will look something like this. Now let's call this point as F. So what happens here is, now the length DE will be equal to DF. Why is that? Because D is the center of the arc and DE and DF are of same length because we have drawn an arc, right? So now we know DE is square root 3, so that means DF, this length, will be square root 3. Or in other words, this highlighted length df is square root 3. So we have found out how to draw square root 3 on the number line. Now, you may actually have a question. Let's clean this up. So let's say if we had taken our unit square, right? And if we would have moved the unit square over here, right? We know that if you put the unit square between 0 and 1, and if you would have constructed the arc, we would have gotten square root 2. But if you would have put our unit square like this, and if you would have drawn an arc like that, so what is this length? So if I name this point as A, and I name this point as B, and let's say this point, so at 0, let's call this point C. So the question is, what is this length from 0 or BC? Can you find out? Can you tell? Remember, this length is square root 2. So from here, if I draw an arc and get this length over here, then AB is square root 2, right? The length A is this point and B is this point. So we know AB is equal to square root 2. So the question is, what is CB? Can CB be square root 3? And answer is, let's find out. So let's say CB is really CA, that is this length, CA or AC, plus AB, right? What is AC? This is 1, because this is 1 unit. This is 1. And from A to the point B, AB is square root 2. Square root 2. In other words, CB is not equal to square root 3. CB is equal to 1 plus square root 2. And we will learn later when we talk about operations of irrational numbers, square root 3 is not equal to 1 plus square root 2. So they are two different numbers.